Hi there and welcome to lesson 2 of our P5 space for reflection topic, and today we're going to be looking at something that you may have covered in maths, where we're going to be looking at vectors and equations, all to do with motion. Anyway, I hope you enjoy this and I will see you at the end of the lesson. Bye. Okay, so our objectives for today's lesson on vectors and equations of motion is, by the end of this lesson you should know and understand what are scalar and vectors in terms of motion, and how to calculate and manipulate equations on motion. Now, you may have heard of the term scalars or vectors, or you may not have, but you will have an understanding already of what they are without necessarily knowing the definitions. Now we're going to start by looking at some examples of scalar quantities. Now, scalar quantities only have a size. So for example, it could be examples such as mass, energy and speed, as you can measure all of those and it doesn't matter which direction that they are aimed in. Whereas if we look at vector quantities, these have another factor that affect them, such as the direction in which they are going in. So for example, force, it could be something like gravity or upthrust, which have a direction involved. Velocity, which is related to speed, but it also has an effect on the direction. And of course acceleration, which means that you need to rely on the direction to see whether you are accelerating or not. Now, the relative speed is the speed between two objects that is relative to each other. Now, we're going to have a look at a couple of examples here. Now, if we look at car A, it's travelling at a speed here of 10 meters per second in this direction. Now, car B is travelling at 10 meters per second as well, so they're both travelling at the same speed, but one is travelling in this direction and one is travelling in this direction. Now, this means that their relative speed to each other is 20 meters per second, as one is going in one direction and the other is going in the opposite direction. Now, if we have a look at example 2, here we've got car C. Again, this is travelling at 10 meters per second in this direction. And car D, this is travelling at 8 meters per second, but this one is also travelling in that direction. Now, this means that the relative speed is going to be 2 meters per second, as it's the difference between the two as they are travelling in the same direction. Now, in terms of velocity and displacement, we can have a look at how we can do a couple of calculations. Now, the first one we are going to look at is this one here, where we can calculate the final velocity if we know the initial velocity, the acceleration and the time. Now, we're going to introduce the symbols for these. You might be familiar with these already, where the final velocity is v, the initial velocity is u, acceleration is a, and lowercase t is time. As a side note, a capital T is temperature. Now, the second equation we are going to look at is this one here, where the distance travelled is equal to the initial velocity plus the final velocity divided by 2 times the time. Now, this, you might notice, is almost like a mean average. So the initial, the final, and then that works out the mean velocity, and then you've got the time that it travels here. Now, this can be put into these symbols, where you've got s is the distance travelled, u is the initial velocity again, v is the final velocity, and lowercase t is the time. So let's have a look at a couple of examples. Okay, so here's the problem. A bike is travelling at a distance of 5 meters per second, accelerates at 3 meters per second squared for 5 seconds. Now, the initial problem is, what is the bike's final velocity? Now, of the two equations we've looked at, the first one is where we can find out what the final velocity is. So v is the final velocity is equal to u plus a times t. So if we show our working out for this, our initial velocity from the question is here, is 5 meters per second. So let's put 5 in, plus a times t. Now a is 3, and t for this is 5 here, 5 seconds. So 5 plus 3 times 5, because we need to do this stuff here in brackets first. 3 times 5 is 15. So 15 plus 5 is equal to 20 meters per second. Okay. Now the second part of the problem is, how far did the bike travel? So if we have a look at this equation where we've got s is the distance that we're trying to work out, the initial velocity and the final velocity we've got divided by 2 times t. So if s is equal to u plus v, so u is 5, so let's write in 5, write with a pen rather than a laser pen, plus the final velocity that we've just worked out is 20, divide that by 2, and then we need to times that by t, which again is 5 here. Okay, so 20 plus 5 is equal to 25. Divide that by 2 is 12.5, and times that by 5, we come out with an answer of 62.5, and the units for this are meters because it's a distance. Now, in order to calculate the same factors again, the final velocity and the distance, we can use a couple of slightly more complex equations. Now here we've got the final velocity squared is equal to the initial velocity squared plus 2 times acceleration times distance. So we'll work through a problem on this. Okay, so a runner starts a race and accelerates at 2.5 meters per second squared for the first 20 meters of the race. What is the runner's final velocity? So, if we put our equal sign, let's substitute the letters here for the numbers in the question. So, the initial velocity is obviously going to be 0 because they've started a race, so they would have started at 0. So 0 squared plus 2 times the acceleration, which is 2.5, times the distance, which is 20. I'm just about squeezing that on the end there. So I'll tell you what I'm going to do. I'm going to bring all of this over here this way a little bit. Okay, so that equals 0 squared is going to be 0 plus the 2 times 2.5 times 20. So 2.5 times 20 is equal to 50. So 0 plus 2 times 50 is going to equal 100. Now, if we look, this is equal to v squared. So to find v, we need to do the square root of 100, which is equal to 10 meters per second. Okay, so let's have a look at this problem here, where we have a car accelerating at 20 meters per second, which accelerates at 3 meters per second squared for 20 seconds. So how far has the car travelled? So here's the equation we're going to use, where s is the distance travelled, u is the initial velocity, t here is time, and t here is time, but it's time squared, and then a is acceleration. So I'm just going to put the equal sign over here. Now the initial velocity is 20 meters per second times the time, which is 20 seconds, plus a half times the acceleration, which is here, which is 3, times 20 squared in brackets. So 20 times 20 is 400, plus, now 20 squared again is 20 times 20, so 3 times 400 is going to be 1200. Times that by a half, we're going to have 400 plus 600, which therefore will equal 1000 meters. Now, vector sums are where we end up with a resultant force. Now, if we have a look at two forces going in this direction, okay, so we've got one force here and a second force here, our resultant force is going to be equal to, so our resultant force is Fr is equal to F1 plus F2. Now, if we've got one force going in this direction and a second force going in this direction, then our resultant force is going to be Fr is equal to F1 minus F2. Okay, so if this is F1 here, and that will be F2, that's where we get our resultant force from. Now, if we have two forces going in opposite directions here, oh sorry, not opposite, but one direction this way, one direction this way, the resultant force is going to be going in this direction. So this is going to be Fr. Let's get that right. So, in order to calculate Fr, Fr is equal to F2 squared plus F1 squared, and then we square root that. And you'll probably be familiar with this with Pythagoras' law. Okay, so that's the end of this lesson where we have looked at the vectors and equations of motion. I'm just going to say one thing that you'll need to remember, and that is the word suvat when you're doing those complex equations. What you can do is you can write down suvat, then you can see what you've got, and you can put a question mark next to the one you need to work out. So it might be this one, and then you can put in X, Y and Z for all of those. Anyway, I hope you've enjoyed today, and I will see you next time.